But first of all, welcome to this workshop. So in this workshop, we are going to talk about agents and MCP. So we are going to create an agent from scratch. And I don't think this actually is correct. We are going to create an agent from scratch. And we are going to look at different frameworks. So first, we will just implement an agent with just using OpenAI. Then we will look at frameworks like PydanticAI and Agents SDK from OpenAI. And then at the end, we will also we will look at MCP, which is a convenient way of exposing tools to different agents. So that's the plan for today. A few words about me. My name is Alexei, and I've been working as a course instructor for maybe 5 years already by now. So I have taught thousands of students. And I'm running Datadogs Club, which is a community of people who love data. We regularly have courses there. And also I'm running a course zone. So this is the course. We will talk about this course more during the workshop, and I'll mention it at the end. But what we are going to cover today is going to be module 2 of this course that I'm building. So I want to agents and MCP. I want to change this thing because this is not the right description, and this is what I'm going to send to you right now. So this is the workshop, the content we are going to go through today. And let me find chat. Yes, I see questions about recorded videos. Yes, at the end, I will send you a recording once it's done. So probably tomorrow, I will upload this video to my YouTube channel and you will get a link to the recording. Okay, let's get started. I hope everyone is ready. What you will need for this today is you will need Python. I hope you have it installed already, and you will need to have an OpenAI key. Other things are optional, like we'll also explore other platforms like Anthropic. So if you want that, you will also need to get a key. I'll quickly show you how to get a key from OpenAI. So you need to be logged in. I don't know why I'm not logged in. So let me log in. So, and then you go to dashboard here. And here you go to API keys. Then you create a new key. So you can also select which project this is for. So probably you will have a default project. So then you create a new key, and you will need to use this key for this workshop. So you put it. The variable name should be OpenAI API key. So then this is the environmental variable you set for the key. So I assume what I say now makes sense. So if you don't know what it means, how to configure OpenAI to your Python client to work with OpenAI, you can ask ChatGPT. It's helpful. It can explain what to do. So what we are going to talk today is agents. And agents is a very convenient way of turning your chatbots into something that can do things. So I'm going to open my ChatGPT. So ChatGPT, you all know ChatGPT, right? And here you can ask anything. Hey, so you can ask, I don't know, what's the boiling temperature? And the LLM, this GPT-5, it knows a lot, so it knows enough to answer this question. But we can also equip our chatbot with some tools, so tools that add extra functionality to our chatbot. So for example, in case of ChatGPT, you can say, generate me a picture of a happy dog. So what happens right now is it has some tools, some extra models. And right now, so this ChatGPT is actually an agent, and it invokes a tool, image generator. And it says, hey, like the user wants this, please do the stuff. And right now, so it invoked the tool. And now we see an image of a happy dog. Okay, that's funny. So it was actually quite fast. I'm surprised how fast it was. So that was an example of tool use. So our agent, so this was an agent and it has some tools. It also has access to Python and search and other things. So what we're going to do today is we will build an agent, a conversational agent that helps students of a course. So we have FAQ documents like that. So this is FAQ of one of the courses we have. So this is a data engineering course. And I don't know, my screen is kind of weird. Okay, so now it's so now you see that it has this format. So there is a question, there is an answer, question, answer, question, answer. So what we want to build is a conversational agent that can look up answers to the students' questions in this database. So what I did previously is I parsed this into JSON. So this is how our documents look like. So we have the question and then the section of so this is for this course, and this is the answer to this. So if you're interested in how I turned this Google document into JSON, you can see the code here. I also linked it. So I will not explain it now. So you can just go through this and see what's happening. Right, but there is some parsing logic for extracting the FAQ into more structured format. So we have this, and we want now to use that to answer student questions. So that's the agent we are going to do. So what I will do now is I will go to agents MCP. So this is the folder where we are going to do everything. So I shared the link to this folder, and I'm going to use UV for dependency management. So if you don't have UV, you can install it with pip install UV. Right, I already have it. So what I will do is I will say UV init, and then I will install something. So we will need Jupyter. We will need requests. We will actually need a bunch of libraries. So requests, Jupyter, MinSearch. I don't know why I didn't include the dependencies here in the description, but I'm doing this now. MinSearch. For now, this is probably enough. OpenAI, right? So Jupyter request, MinSearch, OpenAI. Yeah, we will see. Probably I will need to include some other libraries, but for now, this is okay. So we have our virtual environment now with these tools. So now it will install them, and I will start Jupyter. So there I want to get this document, I want to parse it, and I want to index it in such a way that we can perform search. For that, I will use a library that is called MinSearch. So this is a simple in-memory database. In-memory means that once we finish our process, once we close our Jupyter notebook, once we end the session, all the changes we did to this index table disappear. So this is not a search engine like Elasticsearch, where everything is it's persisted, like the changes when we stop it and run again, we have the changes. So this is in memory. This is very simple. So did it install? So I'm going to run Jupyter right now. And we are going to get the documents and we are going to index them with this in-memory search engine. I think I don't need this anymore. So I'm going to create a new notebook. and I will call it notebook. I will commit this notebook after we finish. So the first thing I want to check is I want to import our OpenAI client and do OpenAI like that to check that it's configured correctly. So you see, it didn't raise any exceptions. It means that I configured it correctly. If you see it complains about the key, so what you can do is, first of all, I mentioned that you need to set up this environment variable, OpenAI API key. Alternatively, when you have the key, you can put it here, API key, your key. Right? But be very careful and make sure you don't accidentally commit this key to Git. Okay, so OpenAI works. That's good. Now let's do the indexing thing. So let's download the data. So here I don't want to spend a lot of time explaining what this is doing. So what's happening here is we get this documents from here. We're doing a bit of processing here. And now I'm going to put this into the index. So index is something we can use for searching. So for example, when I finish this, I can search for how do I just discovered the course. Can I join now? So this is our search function. So you see it returns some things. We can also, so this is our question or query. So this is our query. We can also add some filters here. Filter. So filter could be, let's say we have, so not let's say, we have different courses, right? And when we build an agent, we usually build it for a particular course. So let's say there is a student who takes machine learning Zoom camp, which is our machine learning course. We don't want to show them the answers for a different course. So for us, we only want to show, let's say, our data engineering course. So we have the filter, query. It doesn't. Okay, query, filter. I have a typo here. And now we are able to, I think a Zoom camp, I made a typo here. So now we only see documents from this data engineering Zoom camp. I can also add the number of results, let's say only 5. So now this is how we can control it. So I put together this inside a function. So this is how our function looks like. So it gets a query, then it performs search. It returns only 5 results. And also you have this, you see this boost parameter or boost argument. So what it does, it gives this question field more importance than other fields, right? So it's 3 times more important. It means if the question that the student is asking matches the question in our FAQ database, then they will sort of have priority over other fields. Okay, this is our function. And now we want to use this function. But let me quickly check. I see that there are some comments in chat. Okay, yeah, there is nothing important as I see in the comments. Okay, continue. So now we want to use this function in OpenAI. So when we just use OpenAI, let me quickly check, get this code. Somebody is trying to record the meeting, but I think I am recording it. So I don't know. I just declined the request. So this is how we use OpenAI. So let me just do OpenAI client, OpenAI. So this is how we use OpenAI. So let's say we have some messages. There could be a message from me. So so this is what we do. This is how we create just usual chat bots without agent capabilities. Is we just ask it questions like what's the boiling temperature of water, right? So we ask a question, we get back the response. It's out text, right? So we get the response. So that's it, right? So it doesn't have any tools. But what if we ask it? I just discovered the course. Can I join it now? It has no idea what the course I'm talking about, right? So it says, yeah, check the following. So it gives a generic answer. So we want to give it a way to access this search function. So for that, we need to describe this search function. So we need to say that the name of this function is search, it has this query parameter, and yeah, things like that. So we need to define a description like that. So this is a language agnostic description because we can communicate with OpenAI using different languages, be it JavaScript or Python or Go or whatever. So then we just give it a description like that. We say, the name of our function is search. Then we give the description of this function, and then we describe the parameters. Right. So this is the description, and now we can pass it here. We can say now you have access to tools, and now let's see what it returns. So did I not execute it? Yeah. Now we can see that this is the response. And in the response, in output, we see that we have that it actually decided to invoke a function, our search function, and the query is join course now, right? So we can just do this, query join course now. So this is the result. Then we need to put these results back. For that, we will need to encode them. So let me add an import here, import JSON. So we'll encode the results using JSON. Also, let me put this thing here. So what I will do now is I have the result, right? So I will now turn this JSON to JSON. So now we have a JSON string that we will put back to our agent. JSON. And yeah, so we have that. Now we will need to, so right now, the first time we said this, we asked, I just discovered the course, can I still join it now? So it made a decision to invoke this function, right? We are invoking this function. And now after that, after we have the results, we need to execute this again, right? Which means that here in chat messages, so first of all, we need to add this thing. So this is the model has decided to invoke the function. So we need to add this to history. So then next time we invoke, it has the entire history of what was happening. Right. So actually, I should have used extend. Sorry. So let me correct this. So response, I will extend. Extend means add everything that we have in this list to this list. So right now our chat messages look like that. The first we have the question from the user, then the decision of the LLM to invoke the function. Now we need to add the result of the invocation. So we have the decision, we have the JSON file with the results. Now we need to add this to chat messages too. And after that, we invoke the function one more time. So for that, I have a piece of code here. that I will copy. Yeah, so here the call ID is this one. So I will now simply put it here. Then we have result JSON. And now I invoke it one more time. And right now, when I look at the response, I can see that we can just look at content to output, sorry. So we see that right now, and we have output content. No? Output 0. Then content 0. And then text. Yeah. Yes, you can still join the course. So what happened, it made a decision to invoke the function. Then we invoked it. Then we added everything to chat messages. So this is how it keeps track of the things that have been happening. And then it shows the final result. So the reason we need to add this is LLMs, they are so-called stateless. So there is no history and there is no memory between the two invocations. So when we invoke it here and when we invoke it second time, it doesn't know about the previous invocation here. So the way to preserve the history, the way agents have memory, in case of LLMs, is the memory is here in chat messages, right? So when we send entire conversation again, it knows that that was the original question, that was the decision to invoke the function, that was the output of the function, and now it can answer the question. So this is how we do this. Typically, when we do this, we also have a so-called system prompt. So these are the set of instructions we give to the agent. We say, hey, you're a helpful assistant for the students of this course. Your job is to answer the questions of the students. You need to be very clear. So all the instructions that we have for our agent, they go here. So I have some instructions that I prepared. So I call it developer prompt. So system prompt, developer prompt, they're kind of the same thing. So you're a course teaching assistant, you're given a question from a course student, and your task is to answer this, right? And then we put it here. So, and then actually it's developer. The role of this is developer. And this is the developer prompt. And this is the question from the user. Let me put it separately. Oops. So we have these two. And now, wait. And now we have this, right? And then we do what I described. We can also instruct it to perform multiple searches. We can say, hey, don't just do one, do it multiple times. Do you have an example? Make multiple search. So let me actually copy this. So this is more elaborated instructions. So we say you're a course teaching assistant. Then we ask it to explain why it makes certain decisions. And then we say make multiple searches, right? So we say don't just make one search, make multiple. So let's say what changes if we do it this way. So right now, I expect okay, so it gives an explanation because I asked it if you want to look up the answer, explain it, right? So first it makes an explanation of the decision it made. So we have some sort of reasoning in codes. And then we have the function call. Okay, so join course enrollment deadlines. So we have two things here. So what we will do now is we will iterate over them. And we see that when we look at the output, the first thing is type output text. If M3 type output text, then we just display it. Print M3. I will look at questions now. I see that there are 7 questions. I'll finish doing what I do, and then I'll take a look at the questions. So M3, then content 0 text, right? Does it not print it? Okay, why? Sorry. Content text. I don't know why it's not printing anything. Because we have 2 things. And 3 type content. It's message, sorry. Of course. So now let me remove it. So now it says to determine if you can still join the course, I'll check the information. And now we need to invoke the function. So the other thing was, let me just take a look. Type function call. If N3 type function call, then we do something to process this. So this is what we did last time, right? So we performed the search, we saved the result in JSON, and then we had this thing. So what I will do now is I will create a special function that we will call, I'll just copy it from here. So I will call it make call. So what it's doing, there is a little bit of magic. So first, so the magic is mostly here. So first it's parsing the arguments. So we have the arguments here. So this is JSON encoded. So we parse it to turn it into a Python dictionary. Then we get the name of the function. Then we find, so if I do global search, then I get access to the search function. So if I save it to the F variable, then I can invoke it like here. Right. So there is nothing there, but how do I join the course? Yeah, so I can access a function or everything by name using this. So now I get the function. I invoke the function with this argument. Then I save the result to JSON, and then I return this thing. This is what we will add to our chat messages, right? So this is a very convenient helper function. So I will execute it here. Make call entry result, and then I will append the result here. Append result, right? So, and also we will need to do this thing, chat messages, extend. So all the results that we had, we need to add this to chat messages. And then let me also print this. So we know that there is a tool call happening. So now let's take a look at our chat messages. So I will clean it a little bit. So we see that in our chat messages, you have first the developer prompt, the instructions, then the question from the user, then the response system with clarifications, then the decision of the LLM to invoke the function, and then we invoke the function and we put it back the results. Now we invoke it one more time. So I will now remove it. And what I will do is I will simply invoke it one more time. So it's thinking, while it's thinking, let me check, let me look. Does MinSearch look for exact answers or works like a RAG? So MinSearch uses text search So it's not vector search. So it looks for exact matches, yes. There is also similarity search. There is also vector search in MinSearch. In this particular case, we use index. So this is a text-based search. In our case, yeah, it doesn't really matter. So here we focus on more on like the adding extra functionality. What exactly is happening inside this function? It's secondary. So you can put whatever you want in this function. So in this particular case, we put a search here, but you can put other things like send email or check weather or, I don't know, add a reminder to your calendar. So it can be anything. So see, I'm guessing since we began writing for agents, readability and documentation will improve across the board. Yeah, I mean, so here is just to explain the concepts. I hope you'll be able to follow. It's not maybe the best, the cleanest code right now, but of course, when you work, let's say in the course, you work on your projects, you want to make it more readable, of course. So this is more like just for exploration, for interactivity, because this is live coding. This is very difficult to make it very neat and yeah. Shouldn't the decision to call a function be a dictionary with a role same as user? Does not just need to be intended the chat history. So this is what you do when you use the old interface. So right now we use this, where it is. They use the responses API, right? If you use the chat.completions API, then you need to specify the role. Right now here you don't. So you just simply put whatever the output you got. So you don't necessarily need to always say role, right? So this is how it works with the responses API. With chat completions API, it's different. I love the iterate style of programming Jupyter notebooks. Yeah, I agree. Is there an advantage to parsing the documentation to JSON as opposed to using RAG with knowledge-based documents? I think you are confusing search and RAG. So RAG is using search for LLMs, and the search in RAG can be anything. It can be text search, it can be vector search, it can be any type of search, right? So RAG is just of one of the approaches. And in fact, what we did here right now is we implemented RAG. So RAG stands for augmented generation. So the R part in RAG is retrieval, and what we have here is retrieval, right? So we use a simple way of retrieving data from our knowledge base. It's just our knowledge base happen to be in a JSON document, but it can be any database, and then it's still RAG. It doesn't matter where it is, as long as we're retrieving some data and we are augmenting our generation with this data, we have RAG. How can we set OpenAI key environment variable that you mentioned at the beginning? Yeah. So I think if you struggle with setting up the OpenAI API key, you just ask, hey, help me configure an AI key, and then it will help you. What are the other API design standards compared to OpenAI? Say chat completion. Yeah, that's another one. So here we use the where it is, was it responses? The other approach is chat completions. So this is the old approach or older approach from OpenAI 2 that many other companies adopted. So probably if we, let's say, use Anthropic and we try to use it with OpenAI client, instead of using responses, we will need to use chat completions. So this will be different, right? So right now I'm explaining how to do it with OpenAI. With other frameworks, with other also with other LLM providers, it's slightly different. I will talk about this later. But also right now, I'm just showing the concept, how it works. In practice, you don't really do this in this low level like we do here. We usually use libraries, and we will use the library too. So for now, I just want to explain you from, have this bottom-up approach. Say, okay, this is how it looks on the lower level, but then we go to the upper level and use the libraries. Okay, I think I covered all the questions we have. What you noticed maybe is, so let me execute it one more time. So first we had, so that was our first iteration, right? So there was, it actually didn't write anything. I just say, okay, there is a decision to invoke the tool. And now we need to make another request. And yeah, so right now we have the answer, but sometimes after the first decision to invoke a tool, it has another. So it says, okay, it looks like I need to explore the topic a little deeper. So then it makes another call, and then it can make another call. So what actually happens is we have this loop. So let me put all this together. So we have this loop. So I'll do while true, and we'll loop until there are no function calls. So let's say we have a variable here has function calls false. Then we have function calls true, and then if not has function calls or is function calls false, then we break. So this is how our loop looks like. So we need to iterate over the responses. We need to send requests over and over again until we see only messages in the reply and we don't see any function calls, right? Because if we see a function call, it means that the model expects us to perform a function call. It expects us to save the results and expects us to send again the results to it, send back, so that it can analyze the results and make the response or make another decision to make another function call. So this is how this loop looks like. So what I don't want to actually write this loop here. What I want to do is use a library that will help us. Inside, it's doing the exact same thing as here. So it has a loop. So this library is called, let me wait till my terminal opens. I can actually open it. It's called Toy AI Kit. So I implemented this library. I created it for the different courses and workshops I'm doing because it helps to simplify the code I'm showing. So this this code I put inside this library. It's in one of the classes here, runners. So we have this code already. So this OpenAI Responses runner. So we have this function called loop. And what is happening, it's a little bit more complicated, but the core logic is the same. So it iterates over it makes a response, then iterates over, it makes a request, it iterates over the responses. And if there are function calls, it continues. If there are no function calls, it stops. And let's use this. So it just makes, it will make my life a little easier. At Toy AI Kit. Okay, so what I will do now is I will use it. So that's a lot of code. I will actually do this line by line. So first, I'll do some imports. So this, I will delete this code. Okay, I don't know what it is. Why it's not working. Okay, so then we have this this code, and then in the next thing is we want to add tools to our agent. So right now what I'm doing is I am explaining how to recreate the code we just did with this library, Toy AI Kit, that simplifies some of the interaction. This library is quite useful if you want to test things. It's not intended for production use, but for us, when we want to play with things and experiment with things, this is quite useful. So the next thing we're doing is we're adding this search tool. So we have this search function and the description of this function. So we are adding it. And then I create the interface. So here, so we saw it was just printing it to the output. We can make it a little more interactive. So you will see what I mean. And right now I don't actually need this interface. So then I create this runner. So this is kind of a simple agent. So what this runner is doing this loop that we implemented, and it can perform this loop over and over again. So we have this chat-like experience. So let's do that. And now I can run this loop. I don't understand why it's not working. So let me just restart it. So let me check how I actually run Jupyter. Yeah, I think the problem was with how I run Jupyter. UV run Jupyter notebook. So when I do it like that, then I make sure I use the environment, the virtual environment that UV created. UV is a package manager from Python. I will need to rerun some code, sorry. So while it's happening, let me take a look at the questions. Nice shirt. Oh, thank you. Yeah, I like it too. Yeah, thanks for including the link. I actually included the link in the workshop description too. Is there a way to get AI assistance directly in Jupyter Lab? Yeah, Visual Studio Code has Jupyter Notebook support, and Colab also has Gemini support. So this is a good way to add AI assistance in Jupyter Notebooks. Okay. Did it actually save it? Okay, I will need to reload some of the things. So I don't see any other questions, right? So let me just, oh, why it's not working? Yeah, annoying. Sorry. Yeah, leave. So maybe this is how I should have started it. Okay, now it works. So I actually didn't run this thing, so I don't know if this will work. So this was just an example. Well, let's see. What is it executing now? Okay, this part. So yeah, all of a sudden everything is slow. Should not be that slow. Okay, maybe while we are talking about this, I will show you. So I like using Cursor, and Cursor and Visual Studio Code has support for notebooks. So if you want to have this assistance in Jupyter, so you can just open these notebooks. I don't know why everything is so slow on my computer. I should have rebooted my computer before doing the workshop, I assume, because now everything is hanging. Okay, but what I wanted to show is like you can just open it from Visual Studio Code or Cursor, and then you have all the support. Okay, hey, what's happening? Why it's not running anything? Hey, should I stop it? I'm sorry, I'm just annoyed by how slow it is. Yes, I plan to put this to YouTube. So Maven, what happens? Maven will give me the recording. So right now, the recording that is happening right now, it is uploaded to Maven. So after this stops, Maven will send me the link to the recording. You will also get an email from Maven with the recording, but also I will get it. So I will upload it to YouTube, and then I will send it to you, to everyone who signed up for this workshop. Okay, this one was faster. Okay, let's see if this one actually works. So this, remember, so we wrote this loop, and now I wanted to replace this loop with this toy AI kit library. And yeah, it's actually, it seems like it's working. So yeah, it stopped. And so we wanted to replace it with toy AI kit. So I see a question from Mona, since you mentioned Toy AI Kit isn't meant for production use. I'm wondering what would you recommend for production grade LLM applications? We will actually cover this in this workshop too. So we will talk about other libraries that are production ready. Specifically, it's OpenAI Agents SDK and PydanticAI. So we'll talk about that. But for now, what I want to do is I want to finish this Toy AI Kit application. Chat interface will be Python. So these are some just some helpful classes. I will explain what they do. So they are for displaying. So let's say we have this prompt. How do I install Kafka? Right. So we can run this right now. So what runner.loop is doing is exactly this. It just looks a little like there is a little more logic there. So now we see all the messages, and the last message here is this, right? We can display it. So we have this callback. Chat interface. So we can actually see what's happening. So, which is a little nicer than what we had before, right? You see this function call, search, install Kafka. So then we can expand it and see what was the arguments, what was the output. Was actually multiple search calls. So install Kafka and installing Kafka guide. So right now, I think it's on the second iteration of the loop. So it got all the results from the first loop, from the first query, from the tool invocation, and now it's processing them, and it will show us the results. So I'm a little worried about the time. I think we will need to take a little more time because, yeah, I had this technical difficulty, which probably took like 10 minutes to resolve. Anyways, so we get a response from the LLM. And this toy AI kit is just like it's displaying a little nicer the output. So it's processing Markdown and then showing it as HTML. Right, and then if we want to make a follow-up call, so you see that it asks us a question. Are you looking for specific installation setup like Windows, Mac OS, or using Docker? So what we can do is, so imagine we have this chat-like application where we can ask things. So right now it's asking us, hey, are you looking for anything specific? So we can say, yes, we do. We are looking for anything specific. But as I said, these LLMs, they are stateless. So we need to include the previous history. And for doing this, we include previous messages in the conversation. So now we will continue from here. right? So now it will actually, this is wrong. So I wanted to say Docker, right? So I'm looking for specific installation setup like Windows or using Docker. I want to use Docker. Right, so we gave it, so it already knows that we are talking about Kafka. Now we specify that we want to run Kafka with Docker. So now it gives us some setup with that. And or what we can do instead is we can just say runner.run. Don't need to actually include anything here. And how do I just discovered the course, can I still join? So now we have this chat-like interface. Now, deadlines. I don't know if we have any information about deadlines in the FAQ though. No, I just write stop, and we get the entire history here. So what I should have done is adding this column here. So then we don't really see, or maybe messages. Okay, so I will not run it now because I think you get some ideas of what we can do with agents. I want to just explore more functions. So what we have here, this is called function calling. So we define a function, we describe this function, and we pass it in the list of tools. And now we can invoke this function. So there could be multiple functions. And what we can do is actually Toy AI Kit and also other libraries that we are going to use. They can come up with this description automatically, so we don't need to provide it. What we can do is we can add a docstring to our function, and then it will it will build the description automatically. So let's do this first for our search function. I think I already have here. Yeah, so you see what I have. Oops, I'll close the chat. So here I just asked ChatGPT to give me a docstring at type hints. So here we describe what the input is, what the output is, and here we say that the purpose of this function, right? So now when we use these tools, so instead of adding the tool description, we can just say, hey, agent tools, add search. And now when we do agent tools, get tools, we get a list of tools. And this is the kind of the same description as we have here. Search tools, search tool. So this is the description that we will send to an LLM. And in fact, what is happening is we just send this agent tools get tools when we invoke the LLM. Right? So we can add as many tools here as we want. So for example, if right now we have a search function, right? So something that searches. So right now we implemented simple RAG. So we can look up results, we can summarize them, and we can give back the answer. So this is simple RAG. But what if we want our agent to do more? What if we want to add something back to FAQ? So this is something that simple RAG applications cannot do. In our case, we can add another function. We can add a function that we will call add entry. So this function will add a new document to our index. So here's the description, add a new entry to the FAQ database. And when we do this, we can also say agent tools add entry. So now we have multiple tools. We have the search tool, and then we have add entry tool. And when we run our agent, so let me just recreate it. So we will create it. So now it will get a new instance of agent tools. So I will do runner.run. How do I do well in module 1? So then I ask a question. So it makes some function calls, then it summarizes the results. So this was simple rag, but now I can say add this back to FAQ. So now it will make another function call. Yeah, so you see it invokes a function add entry with this is the question, this is the answer. And yeah, it says it has been added. And now when I look at our index.docs, so this is the list of documents, I see that the last document is this. This is what we just added, or this is what LLM added to our database. So you can see that with agents, you can do much more than simple search. You can add any functionality you want. So adding things back to the database is just one of the examples. You can send emails, you can add things to your calendar, or as we saw in another tutorial I had a few weeks ago, we can build a system that generates code for you, that creates Django applications. So we created a Django application. Okay, so this is kind of the main thing about agents. I spent 1 hour on that, but it's okay. So I will need to speed up because I also want to talk about many other things. So I want to make our code a little simpler. So what I want to do is I want to turn this into a class. So I have the code that I will just copy. So my plan was to actually write it. But so what I don't like about these two functions is that we rely on a global variable index. So index is defined somewhere here, right, at the beginning. So here we built the index, right? And we refer to this global variable from there. So it's kind of not a nice design. So I want to, so I used to be a Java developer, and in Java, you take object-oriented design seriously. So because I guess this is still in me, I prefer cleaner design where I specify all the dependencies explicitly that I have. So there, the dependencies are implicit. So they are the dependencies to the global variables. So here I want to say that I have a class which I call search tools, and it has this explicit dependency on the index. And now I simply refer it to, I say, okay, this is the field of that tool, and I refer to this like self.index, right? So then we have this dependency. And right now everything is in a class, and what I can do is, again, when I use tools, I can just say add tools. So first of all, I'll call search tools, which will be this class with dependency on index. And then I do add tools, search tools. So it will go through all the methods of this class, and it will look for public methods of this class, and it will add them as tools. So now when we get agent tools, get tools, we get this add entry and search, right? So what we can do in practice is just define as many functions, as many methods as we want in this class, then just invoke this add tools, and then we have everything we want here. So I really like the design. And then later you just invoke it in the same way, like here with runners.run. Okay, I think this is all I wanted to cover about like using plain API from OpenAI, and then we added Toy AI Kit on top of that. But I think I explained more or less everything that is happening inside, so you have some ideas. Of course, this search tool, these tools might have felt like a bit of magic, but I encourage you to actually go and explore, take a look at what is happening inside. So here you have this tools class, and that is implementing this. So when you, so this is generate schema for instance. So what is happening? It just goes through all the public methods of this object, and yeah, you can go through this. I don't think I should spend time explaining it. And one of the things you see, and you look at the piece of code, you don't understand it. What you can always do is just copy this piece of code to ChatGPT and ask it to explain it. So this works really well. I see there are chat messages. Let me check. To recreate a workshop, I just need an OpenAI key. Yes. How do we add this question answer action functionality in a notebook? You mean this chat application, right? So what I did is want to go to this runners. So I showed you the loop, right? So you know how the loop works. What I added on top of this loop here in this runners run. So I had this input thing. So I asked the user for input. And if the input is stop, I stop. And otherwise, if the input is not stop, I put it inside the loop. So instead of hard coding things like we did here, where did we do this with this runner.loop? So I hard coded things here. What we can do is just do this input. I ask, hey, how are you doing? And then this will be returned. So if I say question, print question, how are you? Howdy. And then it, so in this variable question, we have this, right? And then you just put this inside the prompt. So this is how I implemented this. Okay, so Mona, you asked what to use instead of Toy AI Kit, and now I'm going to talk about that. So there are two libraries. First one is OpenAI Agents SDK. So this is one library, and the other one is PydanticAI. That's another library. So we are going to use both of them. So I'm going to install them right now. So I'll do UV at, I think it's OpenAI Agents, PydanticAI. So these are the two libraries we're going to use right now. So they make it, so they have a lot of extra functionality that Toy AI Kit doesn't have. Then Toy AI Kit, as I said, it's a library that I created for workshops, for courses. So it's just things that I explained in the course already, I just put there to make it a bit easier to explain in other courses, right, in other workshops. But this is by no means production code. There are some things you can potentially use in your production code, but I wouldn't rely on it. I would really double check and test everything before putting it anywhere close to production. But these libraries, OpenAI Agents and PydanticAI, they are battle tested. Many companies are using them. So I recommend that you use them or something like LangChain or some other agents library. Okay, so I think we installed it. And so what I want to do now is talk about this agents SDK. I have some code here, right? So we will need to import it. So we will need to import two things. We'll need to import the class agent, and we need to import class function tool. So remember, we have this search function, right? So what we can do is we can put this, yeah, it's taken a while. So we can wrap our tool with this function tool, and then it becomes like it's doing something similar to what we were doing, right? So it turns this into this description that we will send to OpenAI, right? So we will have tools. We have these search tools, right? So search tools has two things: search, right? And then it has search tools add entry, right? So we turn both of them. We wrap both of them with this search tool thing, right? And we call it tools. So this is what we pass to the agent. So agents in Agents SDK, OpenAI Agents SDK, let me call it. Let me give it the full name. So they also need tools. It's actually very similar to plain API. It just adds a few things on top of that. So this is how you define an agent. It's not a joke agent. I think I just copied it from another workshop, FAQ agent. So this is what I'll call the FAQ agent. And then we give it a list of tools, and now we can invoke this agent. Again, writing some of the code for invoking this agent is a little, it takes some time. That's why I put the code for this inside ToyAI Kit. You can see the code here. So this is the function run. So this is what it's doing inside. But yeah, to save us some time, so I'll just use ToyAI Kit again. So because we have, I implemented, I think, for just running these agents from OpenAI. So this is good for testing. So when you develop an agent, you give it some instructions and you want to test it. So this ToyAI kit is useful there, but of course you don't want to use it in production, as I said. So then I have runner, and then with this runner, run. So if I do it like that, you see this is like, okay, like because this is asynchronous. So OpenAI Agents SDK and PydanticAI, they are both asynchronous. That's why we need to add await here. And now we can actually do, how do I do well in module 1? And now it uses these tools that we provided. So now it will perform the search. We should be able to see that it made some function calls and it output the results. So this is, I encourage you to check this code, because at the end, when you actually use these agents SDK, you will probably not rely on ToyAI Kit for this. You will probably want to implement these things yourself, or at least this is actually the core logic. So you use runner to run it, and the rest is just for displaying purposes. So let me stop it. Another thing, when it comes to this agents SDK, you kind of need to wrap each method of a class, which is not convenient. That's why there is, I have this wrapper. So wrap instance methods. So what it's doing is it's going through all the public methods of this search tools object and puts function tool invokes, puts this, like wraps it in function tool. So what is effectively happening is, so this piece of code and this piece of code is equivalent, right? So this is doing the same thing, right? So then we can just pass all the tools. So imagine if we added another method here, then we would need to add it here, right? But here it just comes through the entire object. We don't need to do anything. Okay, this is Agents SDK. And now I want to talk about Pydantic. Before I do this, actually, I want to mention a few things. So when it comes to OpenAI agents, there are very nice things. And what I really like, so there is a ton of things. Like you can see that you have guardrails. What I like is handoffs. So a handoff is, imagine that here in one of the tools, we have another tool, and this tool is actually invoking another agent, right? So let's say, I don't know, write Python code, right? So I don't know, something. Here we can have another agent that is invoking, that is getting a prompt, writing some Python code and returning the Python code, right? Or executing Python code. So what we can do, instead of using this function calling and putting agents inside that, we can just say, hey, we have another agent, and and say that this agent need to be invoked when we want to do certain thing. So you're doing this using this hands-off. There are many other things. You can check it out. Actually, in the course, I talk about hands-off. I have an example with hands-off and with guardrails. So we'll rely on this functionality in the course. Right now, I will not cover it because we don't have a lot of time. How much time do we have? 15 minutes. Yeah, we will need to take a little more time than I initially planned because I also want to cover MCP. We're slowly getting there. So let me quickly cover PydanticAI. So this is how PydanticAI code looks like. It's very similar to what we did. So we import agents from PydanticAI, then we declare the tools. We don't need to wrap tools in anything. So we just have this list of tools like that. Right, and then we just pass them to the agent. So then wrapping, it's wrapping the tools inside the agent, I guess. Right, and then again, I have this, where is it? Instead of OpenAI runner, I have Pydantic runner. And of course, the code is also here, this PydanticAI runner. So this is the core thing, right? So this is how you actually run an agent, but then the rest is just things for displaying, just to make it more interactive. I encourage you to go through this implementation yourself after the workshop. For now, for simplicity, for saving some time, I just want to, I'll just use it. So we replace it. Now we do, it's also asynchronous. That's why I do runner.run. And then, actually, I don't think it will work because it needs, let's see, because I think we should have said, I think I just copied wrong thing. How do I do well in module 1? Let's see if it works. Okay, it works. So what I wanted to show you is we can actually add Anthropic here. So when we specify the model, so instead of saying OpenAI this thing, I can say Anthropic and then Anthropic models. I don't remember the names of the model. Yeah, please open it. So for example, let's take this Claude Sonnet. Right, so now instead of using OpenAI, now we can use Anthropic model. And let's see. How do I do well in module 1? So what we needed to just make one change, right? And now we can use Anthropic. So I configured Anthropic, I pre-configured it. I put the key, Anthropic key inside environment variable. That's why it works. But I just wanted to show how simple it is. So when it comes to PydanticAI, it doesn't just work with OpenAI, it works with other LLM providers too. Okay, let me take a look at the questions. Is there any specific reason why you use UV to install libraries instead of pip or conda install? Yeah, I just want to make this an isolated environment because the libraries I have for other workshops and other projects might interfere with this one. And I also want to make sure I don't accidentally forget any library, any dependency. So you saw everything I installed. So then you can reproduce it completely. What is more, after we finish, I will commit all the code So you will see the exact libraries I used because they will be pinned. You will see it in UV log file. So when you try to reproduce it, you will be able to do it 100%. Vladimir is asking a question about some logic goes into functions that we create ourselves, but some logic goes into the prompt. Where is the border here? And how do we understand what logic comes inside the function and what stays in prompt? So in the prompt, we give the instructions of what to do. And in the function, yeah, let me try to. So functions are doing some things, right? So functions, you need to send an email, right? Or you need to, so there are some things you cannot do with a prompt. So then this, of course, goes to a function. Maybe you also mean what you put the instructions for using the function. This is something you put in the docstring. So this is kind of a part of the prompt, if you may. So yeah, I don't know if I'm really answering your question or if I really understand your question. Yeah, Olga has got to run. Yeah, I'll share the recording. Can you use multi-LLM framework with PydanticAI? Yeah, I just showed it. Does it work with Llama? It does. How do we get Anthropic key? Yeah, it's paid like OpenAI. Can you do a session or UV? So I did recently. You can go to Datadocs Club channel, and I think you just look for UV here. You should find something. Yeah, this one. So I will share it here. Okay, functions equals tools. Yes, so I think I use these terms interchangeably. Okay, so PydanticAI is nice because we can switch between different models. We can also combine agents that rely on different providers. Okay, the last thing I wanted to talk about is MCP. MCP. So this is a really cool thing. It's called Model Context Protocol. And what MCP is really doing is this is what Anthropic came up with MCP. So they say it's like USB, but for different tools. So let's say I have a database. It could be Postgres database, right? If I, as a developer, want to integrate it into my agent, I would need to write something like that, some code like that for communicating with my Postgres instance. Then another developer who is doing a similar thing, they will also need to implement something like that. So many developers across the world will need to implement something similar in order to use Postgres in their agents. So in order to rely on Postgres as one of the tools for the agents, they will need to implement that. Alternatively, what can happen is one person creates an MCP server with all the tools available there, and everyone else uses this MCP server. So MCP server is becomes like a connection MCP server between the tool and the agent, right? So you have this thing in between. So then the agent communicates with the MCP server. The MCP server does any logic, like let's say when it comes to Postgres, it knows how to get information about schemas, it knows how to perform a SQL query, right? So it communicates with the tool, then the tool replies some stuff back, and then MCP server gives it back to the agent. So what we can do here, instead of using tools like that, we can rely on different MCP servers, and there are many of them. So what we want to do now is we want to implement an MCP server for this. So it will do exactly that. It will download these documents .json, it will index them, and it will expose it through two methods, search and add entry, and they will be available as an MCP server. So then any agent can use it. So it could be an agent that we have here running in Jupyter. It could be an agent that we have in Cursor. It could be an agent that we have, I don't know, in Visual Studio Code. It could be any agent, right? So that's the main idea between MCP. So you implement it once, and then everyone can use it. And this is a protocol. So I will now create a new folder. I'll call it MCP FAQ. So I go to MCP FAQ. This will be another UV project for me because the dependencies, they're kind of different. So the dependencies I will have here, they are FastMCP. So this is what we will use for implementing the MCP server. Then MinSearch, requests. So this is for requesting the JSON file. Yeah, I guess that's it. I don't think we need anything else. Maybe ToAI kit too, because there is a nice library, nice helper function that I want to use, so I don't need to AI kit to write code for that. Okay, so now we have this. Let me actually open it. So I have this code here. So what I want to do, the first thing is I will create a search agent file where we will put all the logic, all this logic. So here you already know this, right? Search agents. So this is what we had in our Jupyter. So this is just the tools that we have with search and add entry. And actually, I think from the very beginning, we should have exported this into a separate file. So this is way easier to use. Then we will create another file. So it's main. Actually, UV already created it for us. So what it's doing, it's using request, and it's using MinSearch, and it also uses this search tool from here. So this is the same code as we had at the beginning. So it initializes the index. Then it initializes the tools. So this is our tools, search tools, right? And yeah, so now it just puts everything together. We can quickly test that this thing works by running uv run python main.py. Because here I have this search how do I install Kafka. Right. So right now I'm just testing no module search tools. Yeah, I call it search agents. Yeah, let me search tools. Okay, so right now, so what we did is we put all the logic for search inside this code, inside this script. So now when we implement our agent, we don't actually need to deal with this logic. We kind of separated the logic for agent with the logic for tools, right? So now it lives here. We need to expose this, and for that, we are going to use the framework that we called FastMCP. I think I already installed it. So this is how the simplest FastMCP application looks like. So you have a tool. Here inside the tool, you have a description. Then you also have type hints, and you decorate it with this annotation mcp.tool with this decorator. So now it, when you do this, it exposes it as one of the MCP tools, right? And then what I did is doing the same thing, but for our search tools. So let me add these imports here. And now I want to create a function init MCP. So here, it's the same code that I had previously. So first, I create this MCP server, and then I add annotations. So, but here, instead of adding annotations directly on the tools I have, I just say I have these agent tools, add this annotation mcp.tool on all the methods from this. So we did something similar here when, remember, we used OpenAI Agents SDK. So instead of doing it like that, we did it like that, right? So these two pieces of code are equivalent. So we're doing the same thing here, right? So for all the methods, in particular search and add entry, we add MCP tool on top of them, which means we are registering these methods as tools in our MCP server, right? And if we need to add another tool to our search tools, we just add a new method here, and that's it. So then it will be exported automatically. We will not need to do anything. And the last thing we do here is this mcp.run, right? Yeah, so these two. Okay, so our MCP server is ready. So I will run it now. So we will have this nice thing right now. Let me take a look at the chat. I want to know the secret sauce that lets you iterate quickly on IDEs. Yeah, I guess this is something we should take offline because we don't have a lot of time. Could you explain why you connect MCP to Postgres? It's because document data. So yeah, Postgres was just an example. So there is a common tool that many developers might use, and we want to make this tool available to our agent. Let's say we have a customer support agent, and there are some things that we have in our Postgres that our agent might need to have access to, right? So then there could be another team that is working on the connection to the database, and the agent team is just communicating to the MCP server. So this is like microservices architecture. So that's one thing. When it comes to Postgres, I don't know, could be again this customer support. Maybe you have this customer complaints database table that you want your agent to be able to access. So you just give it access to this through MCP. So this was just one of the examples. So you can imagine that you have any tool, and instead of doing something like that and including this in your agent directly, you expose them through MCP. UV is like virtual environment. Yes, exactly. How to mitigate hallucinations in agent. This is something we will cover in the course when we talk about evaluations. At some point, we will talk about automations. No, not here. But yeah, like I think the foundation that you will get should be enough to do any automation you want. Anyways, so we're running out of time. I think it will take like maybe 15 more minutes to finish. So let's do this. So this is what we see when we run our FastMCP server, and it started. You see this with transports std.io. It means std.io means standard input output. What it means that we can type some things here in the terminal, and it will reply back with the response directly in the terminal. But if I just type something like this, it will not be able to understand what is that, because we need to follow specific protocol, right? MCP stands for Model Context Protocol. So there is a protocol that describes how exactly you interact, how exactly you communicate with the MCP server. So you need to send first you. So this is not what I wanted to open. So first, there is sort of handshake sequence that you need to do to initialize your server. So first you send the initialize request. So you see method initialize, then there are some parameters. Yeah, there is a lot of stuff. We don't need to really know what is inside. But what we see is it replies back with, yeah, basically acknowledging, yes, you wanted to initialize. Here it is. I acknowledge the initialization. Then you need to reply with a confirmation. Okay, I have received this and I initialized. We don't get any response back. And right now, this handshake sequence is established. Right now, we can start communicating with the MCP server. And for example, now we can see what are the tools that are available. So it replies back with the list of tools. I copy it. I will put them here. So it's JSON. Let me format it. So this is the reply we get from the MCP server. So we see that there are two tools, one, two. So the first tool is @entry, and here is the description, the parameters also, the description of the parameters. And yeah, there's another one. So if you notice, if you take a look at this, it's not exactly the same as we had with OpenAI. So if we want to directly use it as tools for our OpenAI agents, we will need to convert this schema to the function description we had previously with OpenAI. Right? But yeah, otherwise it's similar. So we have, it gives us back all the function it has, so we can just invoke it. And this is how we invoke it. So the method is tools/call and then parameters. So we say, okay, the name of the function is search. The argument is query, how do I run Kafka? And we get back the results. So this is how we communicate with the MCP server. Of course, we don't do this by copy pasting things to the terminal. What is happening is our agent or our tool is doing that for us. So first, in the first example I have is we do it with the Toy AI kit. So what's happening is it's doing the exact same thing. So it's just simply copy pasting things like kind of putting this to the terminal and then reading back the results. So you can see the implementation here. When you go to MCP, you have this transport, and in transport you have this sub-process MCP transport. So this is the same as standard input-output. So yeah, it's doing some stuff. I think I didn't commit the last change, but yeah, when you go through this code and when you look at this code, you will actually see the latest changes here. Okay, so, and this is how we actually interact with this. Why my computer is so slow? So MCP, so this is the folder. So this is the command we run. So we need to say which command and in which directory. So and then we have this MCP client, which connects to MCP server, and MCP server is started with this command in this directory. And now we do the same thing. So first we start the server. So this starts the process. Then the second thing is what I showed you. We send the initialize request. Takes a while. Interesting. Okay. Then now we reply with initialized. So we acknowledge it. And now we can get access to the tools. So we get tools. And yeah, here they are in a different description, like a different format, the tools that MCP returns. So what we will need to do now is we will need to turn them into something that OpenAI understands. And for that, yeah, so this is an example of how to invoke a function. So this is the results. Okay, so there is a lot of things. Let's see, for example, we have here what. Let me check what are the keys. So structured content. Okay, so this is the result we get from, is it the result? So this is the result we get from the MCP server. Right now we want to turn this to rapid into the format that OpenAI understands. So for that, I have this wrapper that we call MCP tools. Again, you can check all the code there. And when I do MCP get tools, it's actually doing the conversion in the format we already know, right? And then with this, we can do the agents the way we did previously. So, for example, runner.run. How do I install Kafka? So now we will see that actually it is making MCP calls. So right now it's using MCP, our MCP server, for doing function calling. Okay. And yeah, so this is how you do this. You probably, as I said, you don't want to rely on Toy AI Kit. So this is just for experimenting. So let's say you have your MCP server, you want to interact with this to test that things work, then you can use this Toy AI Kit for that. But when you actually want to go to production, you will want to use something like PydanticAI. And PydanticAI can easily connect to MCP2. For that, so first of all, I want to show you a different way of running MCP servers. So what we had here we use the standard input-output protocol transport, but we can have a different transport. So we can have SSA. I don't remember what SSA stands for, but basically when I run it, it creates a web service, and it is something that can accept a HTTP requests and can reply with. So this is just a usual web service. So there are multiple ways we can export our functionality. So first is standard input output, but the other one is this with HTTP. Okay, it takes a while. So while it is starting, I want to show you how to do it with PydanticAI. So I think we need to install PydanticAI with MCP support, but maybe it will just work without it. Let's see. So I'll test it. So we have this MCP client. So we say we want, there are two MCP. So you want, if you want to have MCP server std.io, that's one transport, and we will use SSA. Right, and then this is where our service lives. So now we can access it. And when I use PydanticAI, so here, so let's also use Anthropic. So instead of specifying tools, here I will use tool sets. And this MCP client is one of the, maybe let me call it FAQ MCP client. So then this is one of the tools in the tool set. And now when I run the agent, where is the code? I just want to copy this thing. So when I run the agent, await runner.run, how do I install Kafka for Python? And now it should actually make an HTTP request to the server, get back all the available tools, see that one of them, search, is useful, invoke the search, and then give us back the answer. Okay, let me see what are the questions there. Oh, can you touch a bit on MCP server registries? I don't know what is registries, to be honest. Servers and events. Yeah, maybe. Secure server encryption. Yeah, so let's just say it's the servers and events. Yeah, I guess. Anyway, so for me, it's just HTTP. So we see that it made 3 calls, function calls. Under the hood, these calls were to the MCP server. Okay, so you saw that with Pydantic, it was super simple to integrate MCP. With agentic, with Agents SDK, it's equally simpler. It's equally simple. Is FastMCP inspired by a Fast API? Well, name, I guess. Registries like Brew registry. Yeah. Okay. So Cursor MCP registry. So this is what you probably meant. So let's say if you use Cursor, so here is a list of things you can connect to. So let's say if you want to do something with Docker, then there is an MCP server that you can use to do some stuff with Docker from your from Cursor. So one last thing before we finish that I want to show you is this. So I'll start a new project. Because I want to show you how we can use this MCP server in Cursor. To TMP. I'll create a directory, MCP Cursor workshop example. Okay, now it will start Cursor. So now I want to show you how we can connect Cursor to the MCP server we just created. When my cursor starts. I'm sorry that everything is so slow. It's very annoying for me too. So I'll have a reminder to myself next time before I have a workshop. I need to reboot my computer. Anyways, now what I do now is I create a file, cursor/mcp.json. And here I define, I list all the MCP servers that I want. So for example, here we have a registry, right? This is called directory registry. Anyways, so let's say I want to include Postman, right? So then I see that this is the, I guess I just click add to cursor. But anyways, so this is where they are all defined. So you can have an MCP server that is global to all your Cursor projects, or you can have an MCP server that is only specific to one project. So right now we are creating it only for one project. I don't remember what to write, so let me take a note. So this one. So I have an example here how to do it with standard input-output too. But in this example, we use this SSA, and it immediately detected this server. So I say, yeah, enabled. And I can see when I go to output. So let me stop stop this for now. I'll hide this. So in output, we see logs for different MCP projects. We see that this is some logs that it was trying to connect. Connection was successful, and then we see that it found two tools. Right, so it's good. We can see that it connected successfully, and now I can say, let me actually copy the prompt I prepared. So this implement Kafka connection with Python, use FAQ to do comprehensive research first, and then explain your choices. Okay, so this is the prompt I have. So you see now it is making calls to our MCP server. So we can see that this was the parameter, this was the result. It's actually very similar to what we have in case of MinSearch. So we can see what it's doing. And then it's checking what is actually here, and now it starts to implement things, right? And then when I look inside here, I see that it uses Confluent Kafka. This is the library we recommend in the course. So it took it from FAQ, and now it's creating, creating other things like config and so on, right? And this is very useful for this particular application when we want to expose, when we want to make available our FAQ database. Maybe this is not the best use case, but imagine you have a library. So in the course, I show, why it's so slow? Docs. No, this is not what I want. Evidently. So there is a library we use for evaluation in the course. And our LLM might not know about this library, or the knowledge it has about the library might be outdated. Because LLMs have knowledge cutoff. Usually it's like 1 or 2 years. So there are many things happened in 2 years, right? New libraries appeared, libraries have changed. So what we want our cursor to do is to rely on the most fresh information possible, right? So what we can do is we can index all the documents in the documentation of a framework, for example, this one, and then we can expose it as MCP server, and then we can say, now, please use this MCP server to actually write code. So, and then instead of relying on some outdated information that was used when this LLM was trained, it will actually use most up-to-date information from this MCP server. And there is an MCP server. So slow. Yeah, I think my computer is that. Okay, I see great presentation. Yeah, I need Mac Studio Ultra, I guess. Yeah. Okay, I want to switch. I guess I just have too many things open. That's why my computer is melting. Okay. What I wanted to do, the last thing I wanted to show is context 7. Yeah, so this is exactly what I described. So this is a thing that can index the documentation from different frameworks. And then you can add this MCP server in your cursor. So in the course, we will implement something similar, but in practice, yeah, you probably want to use an MCP server that is already implemented by somebody, because it's doing much more. But we will learn how to implement things, similar things. Okay, and before, yeah, DeepWiki is very similar. So it's also doing RAC on Wikipedia pages. So sorry, on GitHub pages, right? So it indexes all the pages of a repo, and then you can talk, you can discuss these things. I think data engineering. Okay, my computer is giving up. So I wanted to data engineering Zoom camp. So we have a course, and actually, yeah, so there are many things. How do I do well in module 1? Oh, it doesn't have access to the FAQ, but it has access to all the modules. So then it's describing what to do. Anyways, so one last thing before we wrap up, I wanted to talk was the course. So that what you saw now was module 2 of the course. Actually, in the course, we will look at more things. So in the course, I have 3 examples. So this FAQ example was just one, but then we will also do similar things with YouTube transcripts and documentation. The documentation, as I just showed you, it was evidently documentation. And then we will do some agentic stuff on top of that, similar to what I described. We'll just explore other applications. Then we will talk about testing. Like this is exactly testing and also monitoring. So there was a question about hallucination. We will actually address this. And we will also look at how to implement our own coding agent that constructs Django websites. I did a workshop on that already a few weeks ago, but in the course we will extend it and we will see how to use multiple agents that collaborate with each other to actually do that. And then at the end there will be a capstone project. Okay, so I'll share the link with you here. You will also get a link from Maven after this. And yeah, I'm sorry it took a little longer. I think I should work a little on reducing the content. But yeah, I hope you enjoyed. I hope it was very useful. I will upload all the videos to YouTube. You will get a link soon. And yeah, well, I guess that's all for today. And yeah, hope to see you soon. Goodbye, everyone.